Welcome back, physics fans. Just going to be recording this one. This is day 13 in an advanced 1D kinematics. And this is the first advanced one because it requires two steps. That's what makes it advanced, is that it takes two steps. And you have to figure out what the steps are. So here it is. A car stopped at a traffic light, then accelerates at 0.65 meters per second as the light turns green. So it accelerates at a constant rate of 0.65 meters per second squared. While accelerating, the car travels one block and then crosses the bridge 120 meters long. And if it takes the car 6.9 seconds to cross the bridge, how long was that one block beforehand? So the one question is, this one block beforehand from A to B is what we're trying to find out. There's point C over here on the other side of the bridge, but we want to know what this distance is, this displacement, if you want, this distance. Okay, so we write down the givens, okay, and I'm going to write them down under the picture that I have of this car. Definitely not a Tesla. It's lots of smoke coming out the back here, and it's moving from A to B, then to C. And what we know is that the acceleration through the whole time is 0.65. So we have the acceleration is 0.65 meters per second squared. And the acceleration over here is 0.65 meters per second squared. And we know that it starts from rest here, so the velocity here is 0. So we know the initial speed of this one block is 0 meters per second. This is looking pretty good here. We almost got 3 items, but we'll find out we don't have any more. Okay, so the length of the bridge is 120 meters long, 4 sig figs. D is 120.0 meters. And it takes the car 6.9 seconds. So the time here is 6.9 seconds. What we don't have is any of the velocities. Velocities are gone around here, and we don't have the time over here. So what are the velocities? Let's just try to picture this. There is a velocity here, velocity at B, and there's a velocity at C. And the velocity at B is the initial velocity here. And the final velocity will be the velocity at point C. So those are two that we don't have yet. And over in the one block scenario here, we have the initial, but we don't have the velocity at point B, and that'll be the final velocity. So that's interesting. That's good. The final velocity of block 1, which is the velocity at point B, is the initial velocity of the bridge. So I can already see a pattern here. One of the things I taught you is that once you're given 3 givens, you can use the kinematic formulas to calculate the 2 unknowns. Okay? But the final velocity looks good, but it doesn't look as important as the initial velocity, because if we could calculate that initial velocity, then we know that velocity there, which is that velocity here. Therefore, that is that. And once we get this one, that's that. That'll give us a 3 here, and then we'll be able to calculate D. So we can now picture the 2 steps. What are the 2 steps? We calculate that, which is the same as that. And then we calculate the D. So we don't even need the VF. So I'm just going to erase that part here. What formula do we use now that we have these 3 givens in that? The one without VF that I just got rid of is D equals VIT plus 1/2 AT squared. So it's not a quadratic because we already know the t there. We're going to be able to solve it quite easily here. This is going to be 120 equals the initial speed. That's what we're trying to solve. So I'll put that in black so it stands out. And then the other values. T is 6.9 plus 1/2. A is 0.65 and T is 6.9 squared. So we put in the calculator 1/2 times 0.65 times 6.9 squared. So we just square 6.9, and this term comes up on the calculator as 15.47325. And this is still 120, and this is still VI times, and I'll put it in red this time, 6.9. Red because this is just got to stay the same. Let's figure out the math. We take the 15 over to the other side and subtract it. So we'll get a 104.52675 is equal to this VI times 6.9. This gives us VI is equal to 15.1488. Way too many sig figs, but putting it in there. So that is the velocity at point B. That's the initial velocity there, which is the velocity at point B, which is the final velocity over here. Now that we have the final velocity, okay, we have this blue shaded box. It's 15. Let's just write it in there if you want. 15.1488. How did we? So then there's three things here. We want to solve for D. The only thing we don't have is time. So the formula that we'll use is going to be VF squared is equal to VI squared plus 2AD. And we're going to solve for D. So this is not too harsh. What's on the calculator still for you guys would be 15.1488. And we have to square that. And that has to equal 2 times 0.65 times D. And I'll put D in black there just so it stands out. That's what we're solving for. Okay, so what's still on your calculator, just square it. And then divide it by 2. And then also divide it by 0.65. And you get a distance of 176. The calculator says 5279. So I would just write down 4 sig figs. Probably not even correct to do 4 sig figs, but it's Mr. Curl's way just to do it. We won't worry about the sig fig rules right now. If we had to worry about the sig fig rules, this is just 2 sig figs and that and that, and we square it. We'd have to take a look at it when we're adding it and bringing it together and stuff like that over here, which the rules and how many sig figs. So we're just going to leave that all alone right now and just give you 4 as the answer. So that is a 2-step one. And what you had to do is figure out what you had and how to use it to calculate what you needed. It's a multiple step one, and that's what makes it more advanced. And some of these are definitely more advanced on this worksheet. That's why number 25 has a little asterisk to it. Thank you for listening and enjoying. Remember, subscribe and punch that like button lots of times, or subscribe it lots of times. Anyway, thanks. Bye-bye.